All right, today we're going to talk about nuclear chemistry. So nuclear chemistry has to do with the chemistry of the nucleus. And in the nucleus, you have two subatomic particles, protons and neutrons. The first question we want to ask is, what holds the nucleus together? If you think about it, in the nucleus, you have positive protons, and since they are positively charged, they should repel each other. So if you think about it, the nucleus shouldn't really stay together. Well, what kind of separates them are these neutrons. So these neutrons kind of separate the two. Let me draw it a little better. So you have these protons, and so these neutrons kind of separate them so they can still stay together and they're not as repelled by their charges. We call these strong forces. And so what I want you to understand is you need enough neutrons to separate the protons. And so the correct ratio of proton to neutron so that it's stable, has the strongest strong force, is 1 proton to 1 neutron. So that ratio creates the most stable isotope. However, as you get larger, what happens is, if you imagine this in 3 dimension, you need more neutrons to surround the proton. And so the ratio gets a lot larger. But the number of neutrons doesn't keep up with the number of protons to maintain this strong force. And what happens is it's an unstable isotope. So small atoms usually can maintain a 1 proton to 1 neutron ratio, and this creates a stable isotope. What happens is, as you get larger, you need way more neutrons than protons, and since there aren't enough neutrons in the nucleus, they become unstable. So what happens when these atoms or isotopes become unstable? They emit radiation. So today it's all about radiation today, and this is called radioactive decay. So what is radioactivity? Radioactivity is the release of matter and energy due to the change of the nucleus of the atom. So here we have the nucleus, and the nucleus release particles, and the reason why they're releasing matter and energy is because they want to be stable. And so right now they're unstable, and so they have radioactivity. They're trying to release particles from the nucleus so that they can be more stable. They can get to that 1-to-1 proton to neutron ratio. So what is a radioisotope? So radioisotope is any unstable isotope of an element, usually, like we said before, larger elements. So all atoms with an atomic number greater than 83, they tend to be radioisotopes, meaning they undergo radioactivity. So all these undergo radioactivity, meaning they have radioactivity, they break down naturally. So like famous ones are like uranium, plutonium, all those are radioactive. But anything after atomic number 83 are radioactive. We call them radioisotopes. Okay, so we've talked about how nucleuses have been held together, and that creates a more stable isotope. How larger atoms or isotopes are not able to be so stable, and so they're more radioactive. The next question is, what type of radiation do these unstable isotopes or radioisotopes, what do they emit, or what do they give off? And so there's 3 types of radiation that they can give off. One's called alpha, beta, and gamma. So the symbol for an alpha particle, now you probably remember alpha particles from from Rutherford's gold foil experiment, where alpha particles were emitted, shot at the gold foil. So they have a mass of 4, and 2 of them are protons. So they're a helium atom is what it looks like. They're also written like this. So they could be 4-2 helium or 4-2 and alpha. So alpha looks like this, beta looks like this, and then gamma can look like that. The charge, it's a positive 2 charge. The mass is 4 AMU. For beta, you can have, so that's the symbol for a beta particle. It's a -1 charge. Some people also write it like this, because it looks like an electron. It has 0 mass, it has a -1 charge, 0 AMU. And then the gamma looks like this. Gamma just particles of light. Oh, there's no other way to write it. So they have 0 charge, 0 mass. So these are the fastest. These are the slowest. But these have the most amount of energy. I wouldn't say the most, but let's say these are stopped by, you can stop alpha particles by a piece of paper. These can be stopped by like foil, aluminum foil. And then this is stopped by lead. So if you remember, whenever you take x-rays, they always give you a lead vest to put over your heart or your chest, and then sometimes over your reproductive organs, because this is just to protect you from gamma radiation. Because gamma radiation can basically go through your body, right? And that's how we get x-rays and that kind of stuff. All right, we now know the types of radiation. And so here's your alpha radiation. There's alpha, here's gamma, and here's beta. What I want you to notice is here the alpha, remember, is positively charged, and so it's going to, and so here's a magnet, here's the negative side, here's the positive side. So it's going to curve towards the negative side. And then also the beta is negatively charged, so it will curve towards the positive side, and then gamma has no charge. Also notice that beta, remember, has a really small mass, and so it's something that has smaller mass will be affected more by the charge, will be bend more, whereas something that is bigger, it doesn't bend as much. So notice how this has 4 AMU, so the mass of that is 4 AMU of this alpha particle, and so therefore it doesn't bend as much. So think about if you throw like a baseball versus, I don't know, a ping pong ball, and you had wind blowing, the ping pong ball would deflect faster because it has a less mass, whereas the baseball, it would take more to kind of push or deflect the baseball. Same thing here with the alpha particle and beta particle. And so the last thing you need to know is how to complete these nuclear equations. And they're pretty easy. So, as we look here, basically one side has to equal the other side. So the reactance has to equal the product. So 2, 14, 0. So I know that my mass number here has to be 2. Oops. Let me use, so 214. So you see on this side, 0 plus 214 gives me 214, so we're good. 83 and -1, so this would be 84, because if you say -1 plus 84 is 83, which is right here, right? Now if I go to periodic table and look up 84, atomic number 84 is polonium, so I put PO. Remember, because this is the atomic number here. And that tells me the number of protons, right? All right, so notice when a particle emits a beta particle, it changes the element. All right, let's look at the next one, thallium, TH. So here we have thallium. This should be the top, or the mass number should be 226, because you removed 4 AMU. This should be 88 because you removed 2 protons, and so your new element, 88, is radium. Okay, and then this one looks a little opposite, so you have 92 and -1. So 92 and -1 would give you 91, right? And then 239 and 0 would give you 239. So this would give you, what's 91? This one, PA. So we look at this one. If you look at this, the gammas don't really matter. You have 90 and then 2. So this would be 92 here at the bottom, and then 238. So 92 would be uranium. Okay. Hopefully that helps. We have some extra practice for you right here, and I posted a key as well.